Hello developers, I hope you are enjoying my simplified Python series. So as promised, we were doing the collections review, and the last set in the cousin, in the collection framework is a set. We have already covered lists in the previous session, um, tuples, then followed by dictionaries, and the last but not the least one is are sets. Okay, so let's understand what sets are. Okay, so a set is an unordered collection with no duplicate elements. So what underneath what it does is it basically uses something called the membership testing. Okay, and it eliminates the duplicate entries. For example, let's imagine you have a list, and before adding it to an element, you check if the element exists in the list. If not, then you add it. What this is all set talks about. Yeah, so it's a so let's go ahead and head over to our editor, and then we can see that in practice. All right, so let me create a file, sets demo.py. So in the previous one you already saw how we constructed a list. Okay, so lists are constructed using the brackets syntax element 1, element 2, and dot dot dot. Then you saw the tuples. So tuples are immutable. Once created, you cannot add elements to that. Okay, you can only deconstruct. So those are created using the parenthesis. Just a quick recall: element 1, element 2, element 3, dot dot dot. Then last one we saw a dictionary. A dictionary is created using braces. Okay, and within each braces we saw the key 1, then value 1, key 1 value 1s are separated by colon, then key 2 value 2 dot dot dot, key n colon value n, like this. Okay, so now let's talk about set. Okay, so there are two ways to create a set. If you have already elements, then what you can do is you can use a brace syntax. For example, call it as my set equal to, use a brace, but you don't get confused because brace is also used um, to create a dictionary, right? But those elements are separated by a colon. By default, if you initialize like this and you try to print um, type of my set. So by default, if you have an empty set like this, so by default Python treat that as a dictionary. So let's print that out. You see, it's a dictionary. We can once you print. So in order to avoid that ambiguity, either have elements like this. Okay, now if you run it, now it has become set because you already have elements. What if you have an empty set? Okay, so empty set, so an empty set you cannot initialize like this because by default Python has reserved this empty braces for identifying dictionaries. So instead what you can do is you can call a constructor called set. Okay, and just initialize like this, and if you print empty set, and you can print their type. Okay, print type of empty set, then it is going to tell you what exactly it is. So we can also print the set itself, print my set also. Okay, now if you run this, let's run it. Now you can see it is using the brace syntax, but those does not have a colon, a key value pairs. Okay, instead the elements are separated by commas. So this is class set, and this is an empty set. This is also set. So just remember the syntax. Use the set keyword constructor in order to construct an empty set. Okay. So why do we need set? Okay. So as I said in the introduction, basically it eliminates the duplicate um, values elements. For example, if you have a list, okay, called my list, and lists have 1 2 2 2 2 3 4. Now you want to identify the distinct element, so you can create a set called distinct set and set, and you can initialize by passing the list to that. So you can pass any iterator, okay, and then if you print, let's print that, print my list and run it. So print my list 1 2 2 3 4. So you created a set out of that, and I printed the my list, and let's print the distinct set. Okay. Now if you see that this is the list. Okay. Now if you see in the set, it eliminated the duplicate members, so that is number 2, since 2 was repeated twice. So now it will check if the element is there, yes, it will not add. Okay. So it's a very key tool for in order to eliminate any duplicates. Okay. Okay. So the other thing you have to remember is you cannot access the index operator, the subscript operator. For example, you can say element 1 equal to distinct set of 0 like this to access the first element, because we don't know what first element means. So you will get error. So this will say set object is not subscriptable. So that's not supported. Okay, that you have to remember. So in other data structures, you have used an append. With set, what you can do is you can use an add method and pass an element to that. Okay. So it already figured out we constructed this distinct set with a a list of numbers. So I can just type 5. Okay. And if I print distinct set and run it again, let me clear it, run it again, you see 1 2 3 4 5, the 5 is added to that one. Okay. That's so we use add API to add a single element. Okay. But what if you have more elements to add? Okay. So what you can do is you can use an update API. So API can take more than one element. Okay. So this one is add API takes only one element at a time. Okay, that you have to remember. So let's add distinct set, and we pass elements. It can have duplicates. So 5 I already added. So I will add one. Try to add one more 5. Then I will add 6, 7, 2 6s, 1 7. Let's print it. Distinct set. Okay. Then run it again. As you can see, it said set object is not callable. Okay, because I try to call with that instead of using an update method. So instead, what I have to do is I have to call an update and pass an iterable of that elements. So remove it, pass this one list, and invoke it again. And as you can see, though I have added 5 6 6 7 to this distinct set, but it pruned this 5, and since there are 2 occurrences of 6, it removed 1 and it kept the distinct one. So 1 2 3 4 5 6. That's so now we can use, let's look other APIs. Okay, the remove API. Okay, so the remove API, what it does is it lets you remove a element from the dictionary. For example, I can say distinct set dot remove and pass the element. Okay. So remember, this is, since it's not indexable, so you cannot pass the index. So instead you want to get rid of 6. Okay. Then you can print distinct set again. Okay. So now run it again. Now you see 6 has gone. One caveat with the remove is, if you try to remove the element which is not there, that will return result into a key exception. So you see key error, it said the element 6 does not exist, so that's why it is complaining 6 is not there. So there is one more forgivable one which will not raise error. If the element is there, it will remove. If it is not there, it will silent. So instead of remove, you can use discard. Okay. So it works as remove, which is a safer, but if the element is not there, is forgiving, it will not result into this key error. So let's run it again. So this time what it says is, distinct set dot discard, for whatever reason. Yeah, you see I ran into issue previously, I don't know why. So run it again. So I tried to run it. Oh, because of the indent, I did not give the indent, so it got confused. Okay. So 6 is not there. Earlier it threw an exception, key error, but this time it gulped that error silently. Okay. So what you can do is, there are other operations you can perform on set. Okay, I can create one set 1 2 3. Let me duplicate. I can create one more set. Set, what is the other set? 3 4 5. Okay, I can create another union of it. So I can say s1 dot union s2. Okay. So probably you might have learned in your middle school or high school about the set theories. So what it does, it returns the distinct element of set 1 and set 2, and it will remove any duplicates. Okay. Now I can print s underscore union. Okay. So now let's run it. There you go, 1 2 3 4. So 3 is repeated, so it will consider 3 one time only. So 4 3 is there, so instead of 4 3 I will use 4 5. Okay. So now run it again. So 1 2 3 4 5, that's the result. That is another way. If you are in math nerd, instead of this you can type union, also pipe operator. Okay. So that should also work. So let me duplicate again for brevity. So instead of this one, S1 or S2, the results are same. Okay. Run it again, 1 2 3 4 5. Okay. So there is one more operation, okay, called S intersection. That is set intersection. You can either invoke an intersection API, or if you are a math nerd, you can use ampersand. Okay. So conversely, you can say intersection S2. You can try while practicing. So let's print out S intersection. So as you have guessed, it will return all the common elements found in both the set. Now you can see 1 2 3, 3 is common, 3 4 5, 3 is common. So as you might have guessed the results, it will print the intersection. Okay. So S intersection is S1 and S1. I intersected with S1, that's my bad. Let me intersect with S2 instead. Now run it. Now you see there is a common element 3. 3 is written. Okay. So we saw set union, set intersection. Then let's see set difference. Okay, that's nothing but the subtraction operation. So what difference it does is, it will return only the state elements that are unique to the first set invoked. Okay. So, S diff for difference, I can use S1 minus S2, okay, or alternatively I can say S1 minus S1 difference S2. So, depending on your preference, use any of those. S difference, run it, there you go. So, set S1 was having 1, 2, 3 and set to S2 was S3, 4, 5. So, the difference, 1, 2 are the elements that is not found in set 2. So, this is that is why it return those 2 elements. Okay. So, there is one more called symmetric difference. So, what symmetric difference is? It will return all the elements that are not common between them. Okay. This is interesting. So, sim difference, okay, equal to S1, you can use a cap, okay, that by pressing shift 6 on your keyboard and S2, or conversely you can use S1 symmetric difference with S2. Okay. So, that please try it out, sim difference, okay, and write again, see 1, 2, 4, 5, since 1, 2, 4, 5. So, what it will return all the elements that are not common between them. So, these are the elements 1, 2, 4, 5 are not common, 1, 2 is not common, it is not there, 3, 3 common, it eliminated, 4, 5 is not there, set 1. So, that is the reason it returned 1, 2, 4, 5. Okay. That is all I got. Okay. So, what we are going to do next is probably speed up our game and learn about the user defined functions next time. Okay. So, until that time, keep practicing, okay, keep enjoying your coding. Bye for now.